Now let's talk on the integration of y is equals to ax raised to power n. We recall while we're differentiating this format, we have na x raised to power n minus 1. Now, if we want to integrate this same format, we will have it to give us ax raised to power n plus 1 divided by n plus 1 plus c, with an exception that n is not equals to minus 1. Because if n is equals to minus 1, we are going to have an format of 1 over x dx. And integrating 1 over x dx will give us another thing which will be discussed later. Okay, now let's do this. Integral of x raised to power minus 1 dx. And we know that in this case, our n is equals to minus 1. And our a is equals to 1. Therefore, we have it 1 x raised to power minus 1 plus 1 divided by minus 1 plus 1 plus c. Now this will give us x raised to power minus 1 plus 1 is 0. Minus 1 plus 1 is 0 plus c. Now this will give us infinite. Okay, it is undefined. Okay, so we can just write it as undefined. That is why there is an exception of n not equals to minus 1. Now let's take series of examples on this format of integration to aid our understanding. Let's begin with question 1. Integral of 3x raised to power 4 dx. Now let's remind ourselves of this format, that integral of ax raised to power n dx is equal to ax raised to power n plus 1 divided by n plus 1 plus c. Now in this case, a is equals to 3 and n is equals to 4. Therefore, following the format, the principle, then our a is 3 multiplied by x, and the n, which is 4 plus 1 divided by 4 plus 1 plus c. Now this will give us 3 x raised to power 5 over 5 plus c. Very simple. Another example. Let's take 2 divided by x squared dx. Now, applying the law of indices, this can be written as 2x raised to power minus 2 dx.
They record. They shout.
Now, applying this is our a and this is our n. Therefore, let's apply the formula. A is 2 and n is minus 2 plus 1 minus 2 plus 1 plus c. Solving further, we have 2x raised to power minus 1 divided by minus 1 plus c. And this is the same thing as writing minus 2 over x plus c. Let's try another example. Integral of root x dx. Integral of root x can be written as x raised to power half dx. Now, there is an imaginary 1 here, so we can say this 1 is a and 1 over 2 is n. So applying the principle, just like we have done before, we have this to be 1x raised to power half plus 1 divided by half plus 1. and this will give us x raised to power 3 over 2 divided by 3 over 2 plus c. And simplifying further, we have 2 over 3 square root of x raised to power 3 when we apply the principles of indices plus c. Let's take another example. But before then, let's take a quick look at integrating a constant. Remember that d dx of a constant is equals to 0, because when we differentiate with respect to x of 5, we have 0. Now, what happens when we integrate 5 with respect to x? Now, we can rewrite this as 5x raised to power 0, because anything raised to power 0 is 1. Therefore, in this case, we have 5 to be a and our 0 to be n. Applying the law of the principle that says when we integrate ax raised to power n with the x, we would have ax raised to power n plus 1 divided by n plus 1 plus c. Therefore, our a is 5, our n is 0 plus c, and this will give us 5x plus c. Therefore, we can come to a conclusion that the integral of a constant k, integral of constant k, is kx plus c. Let's try again. We have x 8 dx, and therefore integral of 8 dx will give us 8x plus c. Now, when the sum of several terms is integrated, the result is the sum of the integrals of the separate terms, just like we've been doing in differentiation. Let's take, for example, now we are in number 4. Given that y is equal to 2x squared plus 3x minus 5. Now, when we want to differentiate this, we differentiate each term. Likewise, when we want to integrate this, we'll integrate each term. Therefore, integrating this, we have integral of y dx, and that will give us integral of 2x squared plus 3x minus 5 dx. Now, let's integrate each term with respect to x, just like opening the brackets. Now, when we integrate 2x squared, we remember the principle that whenever we integrate ax raised to power n with respect to x, we would have ax raised to power n plus 1 divided by n plus 1 plus c. So integrating 2x squared, we have 2x raised to power 2 plus 1 divided by 2 plus 1. Integrating 3x, we'll have 3x raised to power 1 plus 1 divided by 1 plus 1. And integrating 5, we have 5x. Now, we know that whenever we integrate 2x squared, we have plus c. Whenever we integrate 3x, we have plus c. And whenever we integrate 5x, we have plus c. Now, instead of writing 3 plus c, you can just have a final one plus c. Therefore, simplifying further, we have this to give us 2x raised to power 3 over 3 plus 3x squared over 2 minus 5x plus c. Let's take another example, the final for this video. Given integral of 2x raised to power 3 minus 3x divided by 4x dx, we can simplify this into the standard form that we are aware of using the law of indices. So let's split the denominator accordingly, and thereafter we know that this will give us integral of 1 over 2 x raised to power 2 minus 3 over 4 dx. Now the next thing to do is to integrate each term. That's integral of 1 over 2 x squared minus integral of 3 over 4 dx. Now this will give us 1 over 2 x raised to power n. Our n is 2 plus 1 divided by 2 plus 1 minus 3 over 4x and plus c. Simplifying this further, we will have 1 over 2 into x raised to power 3 divided by 3 minus 3 over 4x plus c, and this will give us x raised to power 3 over 6 minus 3 over 4x plus c. Let's take one more example for this lesson. We're asked to integrate with respect to t of 1 minus t squared dt. Now when we want to simplify this, we can first open up the brackets, because we know that 1 minus t squared is equals to 1 minus t multiplied by 1 minus t. And then when we open up these brackets, we'll have 1 minus 2t plus t squared. Therefore, we're saying that this is the same as writing 1 minus 2t plus t squared dt. Applying the laws of, open the brackets first to simplify, to integrate each term. So this will give us integral of 1 dt minus integral of 2 dt plus integral of t squared dt. Now applying the principles of integrating y is equals to ax raised to power n, which says that integrating ax raised to power n with respect to dx, we will have ax raised to power n plus 1 divided by n plus 1 plus c. Now we are no longer using x, but we are now using t. So instead of differentiating with respect to x, we are differentiating with respect to t. Therefore, this will give us x divided by t minus 2 t squared over 2 plus t raised to power 3 over 3. And remember our arbitrary constant, which is plus c. Now in conclusion, we have t minus t squared plus t cubed over 3 plus c.